Hello, this is the 10th video on electromagnetism for classes 6 to 10. Can be used by students of class 10 to review. In the previous video, we saw a goldleaf electroscope. So we first saw that you can move charge from a charged ebonite rod or a glass rod to any metal object by touching it. So charge can be transferred. So in a goldleaf electroscope, charge was transferred to the knob of the electroscope. Then the charge moved down the stem of the electroscope, reached the leaves, and because of mutual repulsion, the leaves move apart, they diverge. We also saw that if we first if we put one kind of charge on the electroscope and then the opposite kind, then the charges cancel out. If we put negative charge first and then positive charge onto the electroscope, then the leaves collapse as if there is no charge. So there was also one more phenomenon which we saw, but we did not point out when we were using the electroscope. Even without touching the electroscope, the leaf, the gold leaf, in our case, there was only one leaf, it was responding to the presence of charge in its surroundings. As soon as the charged ebonite rod approached the electroscope, the gold leaf started moving. So why does it happen? Let us see it. Here I'm charging the ebonite rod, rubbing with wool, and then taking the charged ebonite rod close to the electroscope but not touching it. Even before you touch it, even without touching, the leaf responds, it diverges. I have not touched the electroscope. And when you take the rod away, the leaf collapses. When you bring it close, it diverges. So it is acting as if it is charged. Even before charge was deposited, before the charge was moved to the electroscope. So when the charged rod comes close, the leaf responds. And when the charged rod moves away, the leaf collapses again. So this is known as induced charge, electrostatic induction. Okay. To induce is to persuade, to lead someone to do something, to make someone do something. So we saw that in the case of magnetism, when you bring a piece of iron close to a powerful magnet, the piece of iron behaves like a magnet. As long as it is close to the magnet, it acts as an induced magnet. Similarly, when you bring an external charge, so here the charged ebonite rod is the external charge, or the charged glass rod. These are external charges. When you bring them close to the electroscope, charge is induced in the electroscope. The electroscope behaves as if it is charged. So this electrostatic induction was observed in 1750s. And how did the scientists understand it? Scientists used to think that positive and negative electric charges are two kinds of fluids, invisible fluids, which exist in all objects. And usually they are present in same quantities and they cancel each other out. But they are mixed. But when you separate them, or if one quantity increases, if the quantity of one increases, then the object becomes charged. So according to this theory, this metal object has plus and minus charges uniformly distributed. They're all mixed up. And then this is the external charge, which will come if it comes close to this metal object. Then, so as this object, external charge, comes close, the positive charges move towards the external charge, negative charges move away from the external charge. So this is what happens when the external charge comes quite close. All the positive charges are towards the external charge, negative charges are away from the external charge. So this is how the metal object becomes charged. And as the external charge goes away, these these positive and negative charges mix up again, and the object becomes uncharged. But now we know that charges are not fluids, they are particles. So negative charges are the electrons, and the protons are the nuclei or the positive charges. And in metals, the negative electrons are free to move around, but the positive charges remain where they are. So using this model, how do we explain induction? So in this model, the positive charges are fixed, they do not move. The negative charges in the metal object are free to move. This metal object is resting on an insulating support, and this is an external charge, this is negative. So as the negative charge approaches, the negative electrons in the metal will tend to move away from the incoming external charge. So here we can see most of the electrons have moved to the left. They keep moving. Okay. So the charges get separated because the electrons move away. They run away from the incoming negative because of repulsion. And when the external charge goes away, then again the electrons come back and mix, and the metal object becomes neutral. So this is what happens. So we have seen how the electroscope responds because of induced static charges. Now we can charge the electroscope through induction. So how do we do that? So this is our goldleaf electroscope, and we are charging it by induction. So here is the external charge coming close. Okay, so before the charge comes close, in this in the metal part of the electroscope, plus and minus charges are all mixed up. As the external charge comes closer, the negative charges on the electroscope move away from it. So they all move towards the leaves of the electroscope. So the knob of the electroscope becomes positively charged, and the leaves become negatively charged. So you can see the charges move, the negative electric charges move towards the leaves. So the leaves diverge because of the repulsion. So now if I touch this knob with my finger and then provide a path, then all these mobile negative charges, which are free to move and which want to get away from the repulsive force, they are free to run away to the ground using this path. So they all move away. They go to the ground. Okay. And now if I remove my finger, now the path is broken. Now the electroscope is left with positive charges. Okay. So the electroscope has become charged. Even though the incoming negatively charged rod never touched the electroscope has become charged. Now, what about if we bought a positively charged glass rod? Then what happens? Then all the negative electrons will be held. They come close to this approaching external charge. And then the leaves will diverge because of the positive charge. Okay? And then when you touch with your finger, then the negative charges from the ground will travel through your finger and reach the electroscope. So when you remove your finger, the electroscope will be left with an excess of electrons in that case. So we are charging the electroscope through induction. So I'm just using a ebonite rod, rubbing it with wool. So the ebonite rod is negatively charged. Now I bring it close to the electroscope, but I do not touch it. Just hold it close to it, and the leaf diverges as long as the. Now, when I touch it, so I hold it close, the leaf diverges, and now I touch it, provide an outlet for the negative charges. They have gone out to the ground. So now the electroscope is left with positive charges. It is charged. Okay, so electroscope was charged with because of induction. We can do the same thing using a glass rod. You can use a glass rod rubbed with silk and charge it with induction. Or charge the electroscope through induction. So in which case, the electroscope will end up with a negative charge in the end. We have charged the electroscope by electrostatic induction. Now, we look at a device called the electrophorus. This is used for generating charge. So far, when we want to create charge, we take a PVC pipe or a glass rod and rub it, okay, with wool or silk. Now, and we have to keep rubbing each time. Electrophorus is, it generates charge through the use of electrostatic induction. And you don't have to do this rubbing every time. You can repeatedly generate charge through induction. So this was invented around 1760. Produces charge using induction. So what is an electrophorus? The electrophorus is a copper disc. Okay, I'm looking at the disc from the side. It has an insulated handle. You can lift it up by using this insulated rubber or plastic handle. So how do I use this? We charge a styrofoam sheet by rubbing. So one time you rub a styrofoam sheet and charge it. Okay. Styrofoam is colloquially known as thermocol. It's a packing material. So it becomes charged, negatively charged. So when I place the copper sheet, copper is a conductor, very good conductor, metal. When you place it on the sheet, some charges jump through contact. We have seen that charges can be transferred when you touch a metal object. So some negative charges jump to the copper sheet. But that is because of the uneven nature of the surface, only few charges jump. But induction happens. Because there are negative charges on the styrofoam sheet, all the negative charges in the copper sheet will run away as far as possible. So they'll end up on the top surface. And so the bottom surface of the copper sheet becomes positively charged. The charges get separated. Okay. So so the positive charges are held because of these negative charges. The negative charges are mobile. They're ready to run away. So if you touch it, in this position, in this situation, if you touch this top surface, all the negative charge flows off to the ground and this copper sheet becomes positively charged on the whole. So now you lift the copper sheet, use this positive charge, transfer it to other objects and do whatever you need to do with it. Okay, and then come back. Once again, you place it on this styrofoam sheet and the whole process repeats. So you can charge this copper sheet many times. Each time you place it on the styrofoam sheet, touch it, and then lift it up. This is the electrophorus. It's a simple sheet of copper sheet, rectangular in shape, and I have attached a eraser, a rubber handle. So I will lift it up using that insulated rubber handle. Now, there is this sheet of styrofoam, thermocol sheet, which I will charge by rubbing. Okay, now I place the the electrophorus on top of the thermocol sheet and I touch it. So when I touch it, there's a small shock. You get a small shock and a small crackling sound, and that you can sense that some charge has jumped from the copper plate to your body. Okay. So now the negative charge is run away. So now this copper plate is positively charged. So I can charge the electroscope using it. You can see. So some charge has been transferred to the electroscope now. Okay, so now I discharge that electrophorus by touching it again. So whatever charge may still have remained on the electrophorus, I have drained it. It's gone. Now it's not charged. Okay. So now I repeat it. So first of all, again, I discharge the electroscope. So there is some charge. Okay. Okay. So second round, I put the electrophorus back on the thermocol sheet. Again, I touch it. So there was a click sound. So now it's charged again. So this was the second round. Okay, so you can keep repeating it. The charge you only rub the styrofoam sheet once, but you can use induction and charge the copper plate again and again. So this is the electrophorus. So this is an interesting instrument or a machine which was used extensively at one time by our early scientists. Okay, so we have made an electroscope and used it. And we have learned about electrostatic induction. Now we are going to do some more interesting things with static charge, but we'll do that in the next video.